Hi everyone, what's up? Today I want to solve with you this antiderivative right here using U-substitution. So right off the bat you can see that we cannot really substitute any expression in this integrand, okay? Because any derivative that you take for any of the for the numerator or the denominator is not going to give you anything that you can replace back into the integrand, okay? So something that we're going to do is we're going to rewrite this fraction as a binomial, okay? A lot of times when you rewrite a fraction as a binomial, you can get one of the numerator or the denominator to have a constant, a number, and then that will allow you to substitute or to choose a u value, okay? So let me show you what I mean by that. So we're going to rewrite this antiderivative like this. So we're going to say that we know x divided by x plus 5 is going to be equal to 1 plus another number that we don't know yet, so we're gonna try to find that, and I'm gonna say this is just gonna be a, okay? So basically if you have 1 and you add a, we need a value a such that if you add it to 1, well, you can get back this fraction, okay? So now let's find a. Now the only thing that we need to do is, well, we need to say that a is gonna be equal to x divided by x plus 5 minus 1, okay? We just move the 1 to the other side of the equation. And we know this is gonna be the same as x minus x plus 5 divided by x plus 5, okay? Here I just distributed the numerator and denominator. I think you call that in English the happy box method, something like that, I'm not sure. But yeah, you know what I did here, okay? This is just the algebra. And over here, something that you can do now is, well, you can see that we're going to get minus 5 in the numerator, and these two x's, they're going to cancel out. And we're going to get the following. We're going to get that a is equal to minus 5 divided by x plus 5, okay? So now we know that if we add 1 to this expression, we're going to get the integrand back, okay? Which means that we can rewrite this antiderivative as 1 plus a. We know a is equal to this expression, so I'm actually going to write the minus sign in here. So this is going to be minus 5 divided by x plus 5, and this antiderivative with respect to x, okay? So now this is what we have, and you can see that this is way easier to integrate than this using U-substitution, because now you can choose, you can see that just as I mentioned, now we have a constant in the numerator, and that means that, well, we can choose u to be this expression down here, okay? So I'm going to say that let u be equal to x plus 5, which means that du is going to be, the differential of u is going to be simply 1, the derivative of this expression, it's just 1 dx, okay? So now we can, using this substitution, we can write this integral as the antiderivative of 1 minus 5 divided by u du, okay? Notice that dx equals du, so you don't have to change anything in the differentials of the variable that you're integrating with respect to, okay? So now this is very easy to integrate. This is just gonna be equal to, I should erase this and continue down here so that you don't have to, try to look all the way up here, So, this integral is just gonna be, we're integrating with respect to u now, and then we're gonna substitute the value of u back into the original function with respect to x. So this is gonna be u minus 5, and remember this is 5 times 1 over u, 1 divided by u, I'm sorry, and the integral of 1 divided by u is gonna be the natural log of u, okay? And we really should add the absolute value, okay? So this is gonna be 5 times the natural log of u, and of course plus c, okay? And this is gonna be the same as, now we can just simply substitute u into this equation, this formula, and we're just gonna get that this is x plus 5 minus 5 times the natural log of x plus 5, okay? And it's going to be plus c, okay? So now you can differentiate this real quick. You can see that this is going to be 1, and you have 1 minus the 5 times the integral of this function, the derivative of this function. The derivative of this function is going to be 1 over x plus 5 times 5, that is going to be minus 5 divided by x plus 5, and you have the 1 here, the 1 that we were expecting. Well, that's that's what we wanted to get back, okay? So yeah. So, well, I hope that you enjoyed this video, you learned something. This problem, it's really nice to show you that you can use substitution with a lot of formulas, and also including those formulas that don't seem to have the potential or the opportunity to allow you to use U-substitution, because here, well, you don't really have any value that you can substitute for you right away. You need to rewrite this fraction, okay? And that is, a little technique, and a very important, just a strategy that you should keep in mind, okay? So yeah, that's been the entire video. I hope that you enjoyed it, and see you in the following one. Bye.